Hi, I'm Mohan. Okay, in this session, let us study the concept of velocity potential function and stream function. Okay, the first one is velocity potential function and the notation is phi. Okay, it is defined as a scalar function of space and time such that its negative derivative with respect to any direction gives the fluid velocity in that direction. That is, if we derive this velocity potential function psi with respect to x, we will get velocity component in x direction. If we derive velocity potential function psi with respect to y, we will get velocity potential in y direction, that is v. If we derive velocity potential function with respect to z, we will get the velocity component in z direction, that is w. And the properties of velocity potential function includes if phi exits, the flow should be irrotational, and if phi satisfies the Laplace equation, it represents the possible steady, incompressible and irrotational flow, where the Laplace equation is given by dou square phi by dou x square plus dou square phi by dou y square is equal to 0. If phi satisfies this equation, then we can say that it represents a possible steady flow, incompressible flow and irrotational flow. The next one is stream function. The notation is psi. It is defined as a scalar function of space and time such that its partial derivative with respect to any direction gives the velocity component at right angles to the direction. That is, if we derive the stream function psi with respect to x, we will get the velocity component in y direction, v. If we derive this stream function psi with respect to y, we will get velocity component in x direction, that is u. And the properties of this stream function includes if psi exits, it is a possible case of flow, and the flow may be rotational or irrotational. And the next one is if psi satisfies Laplace equation, it is a possible case of irrotational flow. Again, the Laplace equation is given by dou square psi by dou x square plus dou square psi by dou y square is equal to 0. Now let us solve one problem related to this stream function. Okay, this is the problem. A stream function is given by psi is equal to 3 into x into y. Determine whether the flow is possible or not. We have to check whether the flow is possible or not. Here they have given the stream function psi is equal to 3 into x into y. We know that if psi, that is stream function, satisfies Laplace equation, it is a possible case of flow. If psi satisfies Laplace equation, then we can say that it is a possible case of flow. Now consider Laplace equation. Laplace equation is given by dou square psi by dou x square plus dou square psi by dou y square is equal to 0. Now first let's calculate dou square psi by dou x square. First dou psi by dou x. Now differentiate psi equation with respect to x, that is dou of 3 into x into y divided by dou x, which is equal to, if we differentiate 3xy with respect to x, we will get 3y. Now again differentiate, that is dou square psi by dou x square is equal to, if we differentiate again this equation with respect to x, we will get 0 because there is no x term. Now we got the value of dou square psi by dou x square. Now calculate the value of dou square psi by dou y square. First consider dou psi by dou y. Now dou, what is psi value, is 3 into x into y divided by dou y. Now differentiate 3xy with respect to y, we will get 3x. Now again differentiate dou square psi by dou y square is equal to, there is no y term, 3x is a constant, differentiation of 3x with respect to y is 0. Now substitute the values of dou square psi by dou x square and dou square psi by dou y square in this Laplace equation. That is 0 plus 0 is equal to 0. That is 0 is equal to 0. LHS is equal to RHS. Hence the psi satisfies Laplace equation. Hence we can say that psi represent possible case of flow. Thank you.